Hello friends, hopefully you are very good, and this is the second video of complete GMAT crash course. And in this video I am gonna talk about basics of GMAT. So guys, this will be a very long video and I will talk about completely basics, and we will talk about those concepts in detail later. So without wasting your time, let's start with factors. So what is factor? For example, 6 is a number, and if you divide 6 by 3, the quotient will be 2 and the remainder will be 0. So 3 divides 6 perfectly. That's why 3 is a factor of 6, or you can say divisor. So any number which divides another number perfectly with a remainder of 0, so the number is called factor of another number. Okay, so uh, okay, let's talk about prime numbers, and I hopefully you can understand the concept of factors. So prime numbers. Okay, so prime number is a number with only 1 and itself as factor. So 1 and itself. So for example, 5 is a prime number because the factor of 5 is 1 and 5. For example, 6 is not a prime number. Why? Because the factor of 6 is 1 2 3 6. You can check, like we already checked 3 is a factor and 1 or 2. Okay, so 2 is also a factor of 6. You can divide 2 by 6 and it will perfectly divide by 3 and remainder will be 0. So there are like a lot of factors of 6, but the number with only 1 and itself factors is called a prime number. That's why 6 is not a prime number, 5 is a prime number. Okay, it's very basic, you know already these things. And let's talk about the smallest prime number is 2, because the factor of 2 is only 1 and 2, and 1 is not a prime number. Okay, and the number with more than 2 factors is called composite numbers. Okay, composite numbers. So you can easily tell me which is composite number. 6 is a composite number because the number have more than 2 factors. 1 is a factor, 2 is factor, 3 and 6 are factors of 6. So let's talk about prime factorization, and in the next page. Okay, new page. Yeah, so prime factorization. And okay, so prime factorization is like writing a number as a product of its prime factors. For example, 12. So 12 you can write as 4 multiplied by 3. 4 multiplied by 3 is 12, but here 4 is not prime. Okay, so this you can not write. The correct form is 2 multiply by 2 multiply by 3. It's again 12, but here 2 is prime number, 2 is prime number, and 3 is prime number. Every number is prime number. This is the correct prime factorization. Okay, so for example, 980, you have to write its prime factorization. So how you can do it? Like you can divide 980. Okay, so 980 I written here, and you can divide it perfectly. Okay, so 980 you can divide it by 2, the perfectly it will be 490. Then you can again divide by 2 and 245. Then again you can divide by 5. Remember, you have to use only prime numbers to divide it. Okay, then 49, and then you can divide it 7. Okay, then 7 7 1. Okay, so the prime factorization will be 2 multiply by 2 multiply by 5 multiply 7 multiply 7. You can write it as 2 raised to power 2 multiply 5 7 raised to power 2. Okay, this is the correct. Okay, so let's talk about variables now. And okay, we will talk about these in very detail. We will solve so many questions. So variable. Okay, so variable is a placeholder for a value we don't know. So for example, there is a question, I should write it. Find a number such that half of the number is 5 more than you can increase the speed of the video if you like it to do it 1/3 of number. So the question is find a number such that half of the number is 5 more than 1/3 of number. So basically you don't know the number here, so you can assume it a variable like x. So number you can assume it like x. Okay, so you have to find x. So the question is saying is find a number such that half of number. So x by 2 is 5, you can write 5 more than 1/3 of number, so x by 3 plus 5. So you can see it's like complete equation, and you can easily solve it by you know how to solve it. Is very easy. X by 2 you can take it to the left side, x by 3 and 5, then you can take it LCM, and or you know, if you know the trick cross multiplication, you can do it. Like the answer will be 3x minus 2x divided by 6 and 5, then x equal to 30. You can solve it, it's pretty easy. So let me tell you some more questions so you can write it. For example, Bob is 5 years older than John. So you can pause the video and write this in variables. Okay, so I hopefully you written in the variables. So let me tell you the correct. So Bob is 5 years older than John. So here we don't know the age. Okay, so let John is x. Okay, x years. So then the Bob is will be x plus 5 years. So this is the correct form or representing a statement in the variables. So let me give you another example. You can pause the video and write the correct form. So Mary got twice the marks Andy got. So pause the video. So okay, here we don't know the marks. Okay, so for example, let's take Andy marks x, so Mary marks will be 2x. It's very simple, and you can write in opposite way, like Mary marks will be x and Andy marks will be x by 2. And okay, let me give you another question, last question, little bit complicated, little bit. So let's rice cost $2 per kg, and wheat cost $3 per kg. Then Annie spent $20 buying rice and wheat. So here represent in variables. Okay, so here we don't know that it's $3 per kg, no? Okay, $3 per kg. So here we don't know like how much Andy spent on rice and how much Andy spent on wheat. Okay, so let's take we don't know like how much Andy brought rice and how much Andy brought wheat. Okay, so let's take Andy bought rice x kg. Okay, we don't know how much he bought. Okay, and wheat he bought y kg. So we know that the price is $2 per kg, so we can write is 2x per kg. For example, actually, like imagine if Andy bought 5 kg rice, so it will be 2 multiplied by 5 will $10. Okay, So we can write is 3y per kg, 3y kg. Okay, so total he spent $20, so it will be 20 equal 3y 2y. This will be the equation. So now tell me that 47 is a prime number or not. So pause the video and tell me like 47 is a prime number or not. So I'm telling you a trick to find it pretty fast. Okay, so the trick is you have to find next highest number that is a square number. Okay, so for example 7 multiplies 7 is 49. Okay, which is greater than this. So you have to find next highest number that is a square number. Okay, so 7 multiplied 7 is 49. Now you have to check prime numbers till 7. So prime numbers till 7 is 2, 3, 5 and 7. Now just check is there any factor of 47 in these numbers, like any number which is among these perfectly dividing 47. There's no number. You can check it, like you can divide 47 by 5. You will always get a remainder. You will not get remainder equal to 0. Okay, so 47 is a prime number. Yeah, if you find a number here that is perfectly dividing the 47, then 47 is not a prime number. Okay, but let me give you some big example. So tell me that 783 is a prime number or not, and tell me 143 is a prime number or not. Now it will be difficult from that trick. Okay, so I'm going to tell you another trick. Any prime number can be represented in the form of 6k plus minus 1. Okay, but here's the interesting part. If you're not able to represent a number in this form, then that number is not a prime number. Okay, but if you're able to represent a prime number if you're able to represent a number in this form, then it's not sure that is a prime number or not. Okay, then you again have to apply the earlier method I told you. Okay, so you will understand this concept in detail. Let me tell you. So let's take 783. So always try to represent first in this form. So how you will represent in this form? Just divide 783 by 6. Okay, you will get 130. Okay, so and a remainder you will get equal is a remainder you will get 3. Okay, you can just divide 783 by 6, then the quotient will be 130, 780, and remainder will be 3. Okay, so here you cannot represent in 6k plus minus 1 form, like 130 then plus 3 still is not representing. Okay, multiply 6. Okay, so you cannot represent in this form, so this is not a prime number, you can directly say. Okay, so this is not a prime number. But here's the trick. In 143, if you divide it by 6, and the quotient will be 23. Okay, and the remainder will be 138. Remainder will be 5. Okay, yeah, so here you can represent in 6k plus minus form, because 6 multiplied 23 plus 5, you can increase it by 6 multiplied by 24 minus 1. Okay, so in this you can represent, you can calculate it. This is 143. But now you cannot say that this is a prime number. Now you have to apply the earlier method. Okay, because it's in this form. Now you have to apply the earlier method. Earlier method you already know that you have to find a next highest number that is a square number. So that will be 12. Yeah, because 12 square equal to 144. Then you have to write prime numbers till 12, that is 2, 3, 5, 7, 11. And now you have to check is any of this number is a factor of 143. So Yeah, that is oh, no, okay, yeah. You can divide perfectly with 11. If you divide 11 143, that will be perfectly divided by on 13. On 13 you will get 143, the remainder will be 0. So this is also not a prime number. Okay, I hope you understand the trick, and you can do the video a little bit back and see the again method. So okay, so we already talked about prime factorization. So do the prime factorization of 288. Okay, pause the video. Do the prime factorization of 288, that is factors of 288 which is prime numbers. So I already told you how to do it. I am again telling you. 288 you have to divide with the prime number perfectly. Okay, so with 2 you can divide it at 144, then again to 72, then again to 36, and again yeah to 18, again to 9 3 3. Okay, yeah. So then you can write the prime factorization is 2 multiply 2 multiply 2 multiply 2 multiply 2 multiply 3. Yeah, so multiply 3 again. So 2 raised to power 5 multiply 3 raised to power 2. Okay, I hope I again understand the concept. Yeah, so now write the prime factorization of 512. You can write it very easy. 512 you can do by 256, again to 128, again to 64, again to 32, again to 16, then 8, then 4, then 2, then you can write it like 2 raised to power 9. Okay, so now let's talk about HCF. Okay, I will tell you the simplest way to understand HCF and GCD. You can also say this same concept. So HCF is the highest common factor. GCD is the greatest common factor. It's the same name of same concept. Okay, so let me ask you, what is the HCF of 12 and 16? Okay, it's pretty easy. You have to just write the factors of 12. Okay, so factors, I am again telling you, a factor is a number which divides the number perfectly with the remainder of 0. Okay, so what is the factor of 12? 1 is the factor of 12, 2 is the factor of 12, 3 is the factor, 4 is the factor. Okay, 6 and 12, right? And what is the factor of 16? 1 here, 2 here, 4 you can divide it perfectly, 8, 16. So what is the HCF, highest common factor? The name is clearly explaining this. Okay, you have to find the highest common factor. So 4 is the highest, that is common in both, so the HCF will be 4. It's pretty simple. But in the questions, like maybe you don't know the factors of, don't remember the factors of a number. So what you can do is, like, you can write the 12 and 16 here, then just start dividing it perfectly. The condition is both must be divisible. Okay, perfectly. For example, 2, with 2 you can both perfectly divide, like 2 6 is 12, and yeah, 2 multiplied by 8 is 16. Okay, so you divide it perfectly, so it's a common factor. Okay, again you can divide perfectly by 2, 3 and 4. Now you can divide 3 by 3, and you can divide 4 by 2, but not perfectly both. Okay, the condition is both should be divisible. So here you have to stop, because no common factor here, and just multiply this. 2 multiply 2, again the HCF will be 4. Okay, so let's talk about LCM. So LCM, you know, is lowest common multiple. Okay, lowest common multiple. It's very simple. For example, you have to find LCM of 12 and 18. So just write a table of 12. What is 12 table? 12, then 24, 12 multiplied by 3 is 36, 48, and so on. Okay, and what is the table of 18? 18 36, 54, and so on. Okay, So you have to just find the lowest common multiple. So this is the lowest common multiple. So the LCM is 36. It's very simple, but maybe you don't know the table. Okay, so again you have to apply the same trick. You have to write both numbers 12, 18, and you have to start dividing perfectly. Okay, so on 2 you can divide it by 6, 9. From 3 you can divide it by 2, 3. Now you cannot divide here, so just now this time you have to multiply all. Okay, so 2 multiply 3 multiply 2 multiply 3 is 36. Okay, this is the LCM. In the case of 3, you can what you can do, for example, here, because both are not compulsory, for example 12, 18, 25. So here what you can do is you can divide it by 2. You know that 25 is not divisible by 2, but still you can divide it by 2, then 6, then 9, and here you can keep it same. Okay, and then again you can divide it by 3, then 2, 3, 2, 3, and 25. The condition is here, like at least 2 should be divisible. Okay, here any 2 is not divisible, so just multiply all. That will be the LCM. Okay, so let me give you some practice questions. Okay, so find the HCF and LCM of 28, 42, 70. It's pretty easy, just do it. Okay, pause the video and do it. So LCM of 28, 42, 70, you can apply the same trick. You can make it like this and divide it perfectly. You can divide it 2 by 2, then it will be 14, 21, 35. Then you can divide it by 7, it will be 2, 3, 5. Okay, now for the HCF, what you can do is 2 multiplied by 7 equal your HCF is 14, and for LCM you can multiply all. That will be 2 multiplied by 7 multiply 2 multiply 3 multiply 5, and what will be the answer is 420. So this is the LCM and this is the HCF. Now there is a very good trick, like to understand the concept more in detail. You know, HCF is highest common factor. So the thing is, if you multiply the HCF with x, like any number, you will get these three numbers. You can check it, like 28, 42, 70. HCF is your 14, 14, 14. So multiply with any number, you will get this number surely. So 14 multiplied by 2, you will get 28, and 14 multiply, you can write it, or you can do it, it's very simple. You can 3, and 14 multiplied by 5 is 70. Okay, so this is the HCF, because HCF means highest common factor, and it will be available in these three. Okay, and what is the LCM? So LCM is basically, if you multiply these three numbers 28, 42, 70 with any number, for example x, you will get 420. So 28 multiply by 15, you can do it, you will get 420, and 42 multiply by 10, you can do it, 420 you will get, and 70 multiply by 6, you can do it, 420 you will get. Okay, so let me tell you let me give you a very good question. Okay, understand this question. So there is a merchant. Okay, and he have 120 liters of oil of one kind, and let's say 180 liter of oil of another kind, and 240 liters of oil of third kind. Now he went to sell the oil. While filling this oil in tines of equal capacity tines, you can say like a container. Okay, and what should be the greatest capacity of that container? So there is a merchant who have these three kinds of oils, and he want to fill those oils in uh, containers. You can say times is containers, equal containers, equal capacity containers. So what will be the greatest capacity? Okay, so you have to solve it, okay, and tell me the answer. So I can explain, okay. So for example, 180 liter oil is here, 180 120 liter, sorry, 120 liter oil is here, 180 liter oil is here, and 240 liter oil is here. Now he want to fill it in containers. For example, he took some containers here and he start filling it. So these are A number of containers, these are B number of containers, these are C number of containers, okay. And we also don't know the capacity of these containers, so let's assume the capacity is X, okay. Then like he want to fill these in equal capacity containers, so the end result will be 120 will be equal to X multiplied by A, obviously, yeah. And 180 will be equal to X multiplied by B, and 240 equal to X multiplied by C, right? So here you can see you have to find the capacity. Now x is the common factor. So what you have to do to find the common factor, we already understand the concept. Like you can, if I show you the HCF PPT, uh, yeah, oh, sorry, where is my PPT? Come on. Okay, skip it. I told you that if you multiply HCF with any x number, you will get that number which is given, okay. So 120 is here and you are multiplying with x with any number, so x is the HCF here. HCF, you can find this value. So what you have to do is simple thing. You have to find HCF of 180, 240, 120, okay. And it's pretty easy, you can do it and you will find the answer actually. So let me tell you. 10 you can divide it 12, 18, 24, then 6, 5, 2, 3, 4, okay. The answer will be 60. The 60 is the capacity, that is the answer, okay. So guys, now tell me what is the HCF of 1 by 2, 2 by 3 and 7 by 3. Pause the video and tell me the HCF of this. So let me tell you a simple trick to find the HCF of fractions. That is, you can do HCF of numerators and LCM of denominators. It's pretty simple. So HCF of 1 to 7 and LCM of 2, 3, 3. So HCF of 1 to 7 is like you can you know that you have to find a common factor and nothing is common here. So HCF is 1. And in LCM you have to find at least 2 common, na? Yeah. So 2, 3, 3, and here you can divide it by 3, 2, 1, 1, and here is nothing. So 3 multiplied by 2 is 6. So the HCF is 1 by 6. And for the LCM, it's also same, just reverse it. So for example, you want to find the LCM of, again same, 1 by 2, 2 by 3, and 7 by 3. So now what you have to do is LCM of numerators and HCF of denominators, okay. So LCM of 1 to 7 and HCF of 2, 3, 3, okay. So what will be the LCM of 1 to 7 is like nothing is common here, so multiply everything 14, and HCF again nothing is common here, so multiply it 1. So it's pretty simple to find the LCM. 14 is the LCM here. So guys, let's talk about fractions. So first is proper fractions. Yeah, so proper fraction is the fractions when Numerator is less than denominator. If you don't know what is numerator, then that upper value is numerator and the lower value is denominator. So what you can do is, like, a proper fraction is the fraction when numerator is less than denominator. So example, 2 by 3, so 2 is less than 3. 7 by 9, 7 is less than 9. Okay, so let me tell you about improper fraction. So what is improper is, like, numerator is greater than denominator. Okay, so 7 by 4, 7 is greater than 4. 9 by 7, 9 is greater than 7. Okay, and third is mixed fraction, like 2 by 2, 4 by 5. Okay, so what is it actually is 2 plus 4 by 5. And if you know how to solve it, it's very easy. Let me tell you another trick. Okay, so you can write it like write it as 2 by 1 plus 4 by 5. Okay, yeah, write it. And then like you can take it LCM, but better than you can multiply it. So you can multiply the both and write it as like 5 multiply 5 1, and cross multiply it. 2 multiply 5 equal 10, and 4 multiply 1 equal 4. So that will be 14 by 5. So let's talk about addition and subtraction of fractions. Okay, so for example, 2 by 3 plus 4 by 5. Okay, so the actual way of doing this is like you have to take LCM of 3 by 5, these two, and the LCM will be 3 by 5 is nothing common, so LCM is 15. And what you have to do is make this 15. Okay, so how you can do it? 3 multiplied by 5 is 15, and 5 multiplied 3 is 15. Okay, and again the same you have to do above, because it's like same. You have to multiply by 3, so that will be 10 plus above 15, and 12 above 15. Okay, then you can like make it 10 plus 12 and 22 by 15. But I already told you the faster way. The faster way is this, like 2 by 3 plus 4 by 5 is this. So multiply these two, that is 15, and cross multiply these 2, 5 to the 10 plus 4 multiply 3, 12. Okay, again it's same. Subtraction is also same. The sign will be changed. So for example, if there is plus, there's minus, so there will be minus. Okay, and you can do it. Okay, okay guys, so let's talk about comparing fractions. So how you can compare fractions? If I ask you 3 by 4 and 5 by 6, so which is greater here? Okay, you have to tell me. So it's pretty hard to tell by saying this, but you can do is make the denominator same. Okay, so how you can do it? Again, take the LCM of 4 by 6, it will go on to 3, and that will be equal to 12. Okay, yeah, so again you have to make denominator 12 here, and here denominator 12. So how you can do it? Like you have to multiply 4 by 3, then the denominator will be 12, and here you have to multiply 6 by 2, then denominator will be 12. Okay, and again you have to multiply numerator with the same. Okay, so it will be 10, it will be 9. Okay, now you can easily see 9 is greater than 9 is or greater, or 10 is greater. So obviously 10 is greater. Okay, you don't have to see check the denominator. Okay, it's pretty simple, 9 and 10. So this one is greater. So let's talk about fraction multiplication and division. Okay, so if you want to multiply fraction with fraction, so 7 by 13 example with multiply with 3 by 5. So what you can do is like direct multiply. Okay, just write it 7 multiplied 3 and 13 multiplied by 5 is pretty simple, and it will be 21 by 65, right? Okay, and if you want to divide fraction, so example 2 by 5 divide by 3 by 7. So what you can do is reverse this, and it will be converted into multiply. So that will be 2 by 3 multiply 7 by 3. Again you have to do like same. So that will be 14 by 15. Sorry, I written 5. That is, this is 5. Okay, so it's pretty simple. And if you thinking about how I did this in reverse, so like 2 by 5 divided by 3 by 7, you like, it's actually 2 by 3 dividing by 3 by 7, and you can move it here, so it will be rotate, so that will be again 7 by 3, it's equal. Okay, so now let's talk about decimals. So it's just a basic video. Okay, we are just revising a concept, your concept of 10th standard, 12th standard, and then we will go in very detail. We will solve very long questions. Okay, so please like watch the complete course. Okay, so for example 278.325. okay, this is the decimal value, and this is hundreds. Okay, and this is tens, this is ones, and this is decimal, and this is tenths, this is hundreds, this is thousands, and so on. Okay, so like what is this, like if you want to write this decimal in expanded form, so what you can do is 2 will multiply with 100, and plus 7 will multiply with 10, plus 8 will multiply with 1. Then you have to write a plus here in the place of decimal. Okay, then 3 will multiply with tens. Tens means 1 by 10. Okay, then 2 will multiply with 1 by 100, and so on. 5 will multiply with 1 by 1000. Okay, like this. So now let's talk about decimal addition, subtraction. Okay, so for example 9.64 you have to add with 12.7. The simple trick is like just align the decimal points. Okay, so decimal is here, decimal is here. Okay, so 9.64 you have to add with 12.7. so you have to write 0 here and 0 here, and now this just add this. Okay, 4 plus 0 is 4, then 3, and you can take the carry, then 2 2. Okay, by taking it carry. Okay, yeah, this will be the answer. And if you want to subtract, it's pretty same, like just change the sign. So for example like 7.63 minus 2.47, you can do it. I am also doing with you. So align the decimal points, it's already aligned. Okay, no problem. Yeah, you can do it. It will be like what is 5.16. okay, so let's talk about multiplication. Okay, so for example you want to multiply 3.5 with 2. Okay, so what you have to do is like make it easy, just remove the decimal. Okay, so for to remove the decimal, like you want to make 3.5 to 35. Okay, how you can do this, like you have to transfer the decimal to one place right side. Okay, so that will be 35 multiplied by 2, because decimal is here, and if you write it and not write it, same. Okay, then it will be very easy, 70. Okay, so but remember you move the decimal to the right, so at from one place, so here you have to move the decimal is here now. Okay, it's same now, 70 is same, 70 is equal to 70.00, how many you want na. So you moved here one decimal point to the right side, so here you have to move one decimal point to the left side, so the answer will be 7.0. okay, this is the answer. So for example 2.34 multiply 3.12. now it's very hard to multiply with points, simply just remove the points. Okay, so to remove the points, you will move this decimal to the right side with two places, 234, and you moved two places, and here you moved two places also to make it 312. now it's very easy, just multiply it. Okay, it will be 8 and then 6 4 multiply 4 3 2 multiply and yeah 207, and that will be 80037. okay, it's 0. Yeah, so you move total 4 places to the right side, so here you have to move 4 places to the left side. So decimal is here 1 2 3 4. okay, so the answer will be 7.3008. It's very easy, just like how many places decimal you are transferring to the right side, you have to do it on the opposite side to the left. okay, left. So let's talk about division of decimals. okay, so for example you want to divide 33.725 divide by 0.25. okay, so let me tell you a simple trick. okay, so write it as 33.725 and 0.25. so find the decimal part, like highest decimal part. okay, so here is the highest decimal part, 3 digits in decimals. okay, like after decimal. okay, so just multiply 3 zeros like 1000 with both numbers. okay, so multiply 1000 with both. You will understand with another example. okay, now it's very simple, that the upper answer will be 33,725 and this will be 250. okay, and now you can solve it, like it will go on 1349, and you can do it very simply. yeah, 1349 by 10, and it will be 134.9. okay, it's very simple. Now let me give you another example. So if you want to 25.7 and 1.25, so here is the 2 digits in the decimal, so multiply with 100, multiply with 100, and then that will be 2570, and yeah, here 125. okay, so now you can divide it 2570 125, and you can find the answer. okay, you can do it like, okay, you can do it very simply. okay, so let's talk about classification of numbers. okay, numbers classification. So first is your common numbers 1 2 3 4 and so on, that is called your natural numbers. okay, but if you add 0 in these, okay, that is called whole numbers. okay, so 0 1 2 3 4 till infinity is called whole numbers. okay, and if you add a negative number in these, okay, so negative number like -2 -3 -4. okay, so this is, then it will call integers. okay, integers, and integers will contain all, integers will contain negative numbers and whole numbers and natural numbers. okay, you can see the hierarchy. okay, and if you add fractions in these, like my writing is not good. okay, just understand the concept. okay, if you add fractions like 1 by 2 and 2 1 by 3, okay, -4 by 7, okay, these are fractions, so this will called rational number. okay, so rational number is the like written in the p by q form. okay, this is p by q, where q is not equal to 0. okay, so you cannot say like 1 above 0, it's not correct. okay, so this is rational numbers. okay, till here. okay, you learn this concept in your schools. okay, and anything except rational number is called irrational number. So irrational number, you can say like under root 2 is the irrational number, pi is irrational number, and 0.12333 is irrational number. And if you add these two, irrational number and real numbers, rational numbers, so it will be real numbers, your whole world of numbers. okay, so this is the whole concept, and very easy, I think. yeah, so let's talk about how you can distinguish between rational numbers and irrational numbers. Okay, so first let's talk about rational numbers, which is in the p by p by q form, where q is not equal to 0. Okay, so there's two things. One is terminating the decimal expression, terminating, okay, decimal expression. Okay, so for example, 3 by 4 is a rational number, 3 by 4, so you can write it as like 0.75 if you divide it, and it's ended here. Okay, it's ended here completely. Okay, so it's terminated decimal expression, so that's why it's a rational number. Okay, for example, no, like not example. So second thing is non-terminating, but recurring means occurring again and again. Okay, so recurring, don't go on my writing, just understand the concept. Okay, so for example, 1 by 3, if you divide 1 by 3 you will get just 0.333 and so on. Okay, so you can write it as 0.3 bar means it's repeating continuously. Okay, so the thing is here it's not ending, and the end is not here, and it's not here, not here. It's continuously going, but it's not non-terminating, but it's recurring. Okay, it's repeating, 3 is repeating here, so that's why 3 is 0.3, like 1 by 3 is a rational number. Okay, and I can give you another example. Let's say 0.1232323. so here you can see it's not ending. Okay, but it's recurring. Okay, 2 3 here is repeating again and again, so you can write is at 1.23 bar. Okay, again it's a rational number. Okay, so if I if I talk about irrational numbers, so it's opposite. Irrational number, the first thing is they are non-terminating and not non-recurring. Okay, so for example 0.010011000011. Okay, so you can see that here it's you can find a pattern, like here you can see 101, then you increasing, you doubling it. Okay, 0011, then you are tripling it, 000 Okay, but here same thing is not repeating and it's not ending. Actually you cannot say it's like 0.01, it's continuously going. Okay, and the same part is not repeating, it's increasing also, so it's non-terminating and non-recurring. Non-recurring means same part should repeat. Okay, not expanded. Okay, so this is why this is not a rational number, this is irrational number. Okay, if you can see the value of root 2 is 1.414213 and so on it goes. Okay, it's non-terminating and non-recurring. Pi you can see we assume it 22 by 7, but actually is 3.14159 and so on it goes. Okay, so these two both are irrational numbers. Okay, hopefully you understood the concept, and I will open the comments in this video, and you can tell me if anything change you want in the video, anything you have like doubts, and any suggestion you want to give. Okay, and okay, so let's talk about how you can express the decimal expression into p by q form. Okay, so for example there is, let's say, 4.7285. now you have to express this in p by q form. Okay, so it's it's basically terminating decimal expression. Okay, because it's terminated here. Okay, it's not continuously going. Okay, so what you can do is just count the decimal, count the digits after decimal and multiply it, so it will be 4.7285. so there's 4 digits after decimal, so multiply it by 1234, then divide it 1234, it will be 47285, then 140, and it will be, you can do it, it will be go like 9457 and here 2000, and you can solve it. It's very easy to do it. Okay, Now let's talk about non-terminating recurring decimal expression. Okay, so for example 0.333 and it's going on. Okay, so how you can write this in p by q form? Okay, so what you can do is like assume this is x equal 0.333 and it's going on. Okay, now again make this x. So how you can make it x? Like first you can multiply this by 10, both side 10x equal, if you multiply it with 10 that will be 0.333 and going on. Now separate the 3, then it will be 3 plus 0.333, and here you can see this is x again. Okay, so you can write it 3 plus x 10x, and now you can just find the value of x. It's pretty easy, just do it the bullshit things and you will be find that x 3 divided by 9. Okay, okay, so you express this in what do you say, p by q form. So let me give you another example. Okay, let's say 0.3454545 and so on. So here you can again take it as x, and you have to make again this part as x. Okay, so what you can do is you have to use your brain. Okay, so for example you can multiply with x to 100 and it will be 34.545 and so on. Okay, so what you can do is see above that this part is repeating now, and you have to make 3 here. Okay, so what you can do, you can separate the part 34.2 plus 0.3454545 and so on. Okay, see you can if you not understand what I did. Okay, so you can divide like 3.545, let me explain you, 4545 so on. Okay, and you can subtract it, yeah, 3 4 5 4 5 or 5. Okay, and you will get this same value 34.2. Okay, so it's same, if you add these two you will get this. Okay, now what I did is 0.345 is again x, so it will be written as x plus 34.2 equal 100x. so it will be take it here, it will be 99x equal 34.2, and what you can do is x equal 342 by 990. Okay, that's pretty complicated, but I'm going to tell you a very good trick. Okay, it's all about trick because you cannot solve in these long methods in the GMAT exam. Okay, so for example 0.456, so this part is repeating part, you can use a bar on above that. So what you can do is count the repeating digits. There is 3 digit repeating, so it's pretty simple, just write 4 5 6 and write 999. Okay, very easy. Okay, for example 0.3 3 is repeating here. Okay, so it will be 3 by 9 because 1 digit repeating. Okay, so for example 0.25735, here 735 is repeating. So what you can do is again write the same 25735. Okay, 3 digit repeating here, so 999, and 2 digit non repeating here, so 20, and minus the non repeating 25. So it's pretty simple, just do it. 25710 and 99900. Okay, and this is your p by q form. Okay, so that's all for today's video, and let me meet you in another videos.